Okay, so in this video, we are going to answer two problems related to sum and product of the roots of quadratic equation. So our first problem is um, if P and Q are the roots of the quadratic equation 2x squared minus 4x plus 1 equals 0, where P is greater than Q, find the value of the following. So in this case, P and Q are the roots. Number one, we do not need to find what are those values of P and Q, respective values of P and Q. Because what we're going to do is, number one, let's find a way to express this, express all of this in terms of sum and product of that. Okay, so we know that our sum is P plus Q. So this right there. Then we know that that is negative B over A. Okay, from that negative B over A, that's negative 4, negative 4 over 2, that's positive 2. Okay, then our product is P times Q. That gives us C over A, and that is 1/2. Okay, so generally our strategy here is that we are going to express this 1 to 5 here in terms of sum and product, meaning in terms of P plus Q and in terms of PQ. Okay, after we express this in terms of sum and product, we are going to substitute 2 and 1/2 so that we can find the value of this. So it's just like we are rewriting this one into an identity, or if it's not an identity, or simply just an equivalent expression. So let's start with the number one. So we just simply add this one, and P becomes PQ by multiplying Q, and Q becomes PQ by multiplying P. So as you notice, the numerator is Q plus P, which is exactly our sum of the roots. And our denominator is PQ, which is exactly our product of the roots. Okay, so that is our general strategy. Let's find a way by using factorization, whatever identities we knew before, just to rewrite this in terms of sum and product. Okay, so let's substitute. We know that Q plus P or P plus Q is 2, so we can just substitute that there. Then we know that PQ is already 1/2, so it's just saying that how many 1/2 are there in 2. Therefore, that is 4. Therefore, the value of this number 1 is just 4. Number 2. Number 2, this one needs a little bit of explanation. So we're just gonna move it here. If we are going to expand P plus Q square, you get P square plus 2PQ plus Q square. So as you can see on this right side, okay, for it to be equals to P square plus Q square, we just have to remove 2 plus PQ. And how do we do that? Is we're going to subtract minus 2PQ, and this one is also minus 2PQ there. So the middle term becomes 0, and that's exactly becomes P square plus Q square. Therefore, P square plus Q square is just the expansion of P plus square of P plus Q. Sorry, it looks like G. But since there is in the middle term, which is 2PQ, you need to subtract 2PQ. Okay? So as you can see here, as you can see here, this one is actually the sum, and this one 2pq is actually the product. So we'll just substitute it again. P plus q is 1/2, no, 2, and pq is 1/2. So we have 4 minus 1, and that is 3. Therefore, the value of p square plus q square is 3. Okay. Number 3. In number 3, it's like saying p minus q. P minus q. So it's saying that since it is p minus q, it's saying difference of the roots. Okay. This is difference of the roots. But there is a condition here that p, in the problem, there is a condition that p is greater than q. Meaning, the difference of the roots is actually greater than 0, meaning positive, because if p is greater than q and you subtract them, that is positive. Okay, that should be greater than 0. So how do we do that? So the same idea with this idea of p square plus q square. If we're going to expand, just write it here. If we're going to expand p minus q square, that's going to be p square plus q square minus 2pq. Okay, now we can, okay, we are allowed, since p is greater than q, we are allowed to take this because the difference is positive. We are allowed to take the square root of this one. So this becomes p minus q equals square root of p square plus q square minus 2pq. Okay, so this becomes square root of p square plus q square minus 2pq. Okay, so here, as you can see, we do not need to rewrite this again because we have already that value in the previous one, which is actually this one. Okay, so I'll just substitute 3 there, minus 2 times pq is 1/2. Is that 1/2? Yeah, that is 1/2. We'll get 3 minus 1, we'll get square root of 2. We don't need to turn it into a decimal. That's it, because we can, there's an integer square root of 2. So that's it. Then number 4, we have p cubed plus q cubed. Okay, so you can see, number 4 is actually a sum of 2 cubes. Okay, and since this is sum of 2 cubes, we can factorize this one into p plus q. Then that is p square minus, take note of the plus and minus, that make the plus here and the minus here makes the middle terms when expanded become 0, and we are left with p cube plus q cube. So that is pq plus q square, and we can rewrite this further into p square plus q square minus pq. We can just write it like that. Then let's substitute our available values for p plus q. We know that p plus q is 2. We know that p square plus q square is 3 minus pq, which is 1/2. So continuing that, you'll get 2 times 1/2, take away 3 is, that's 5/2. Okay, and twice of 5/2, of course, that is 5. So p cube plus q cube is just 5. So again, the general technique is just to write this in terms of sum and product of roots. Okay, and other available identities if possible. Number 5 is p raised to 4 plus q raised to 4. Okay, so number 5 is p raised to 4 plus q raised to 4. Um, Again, let's try to find the equivalent expression of this. If you are going to expand, if we're going to expand, let's write it here. P square plus q square square, you'll get p square plus 2p square plus 2p square q square, then plus q, that is 4. P raised to 4. Okay, p raised to 4 plus 2p square q square plus q raised to 4. Okay, so we can rewrite this again into, as you can see here, on the right side, this one, in order for this to be equal to p raised to 4 plus q raised to 4, we need to subtract to the same with what we did with the p square plus q square a while ago. We need to subtract 2p square q square from both sides. Okay, so we are left with this one. Therefore, we are left with this one because this becomes 0. So we are left with 4 plus q raised to 4. Okay, therefore p raised to 4 plus q raised to 4 is just p square plus q square, the expansion square of that, but subtracting 2p square q square. Okay, and we can rewrite this further as p square q square, then this one, because we don't have value of p square and q square, we can rewrite that as 2 times p times q square, so that we can substitute the pq, then square. Okay, then let's substitute available values. We have already the value for p square plus q square, that is 3. Then we have also the value of pq, which is 1/2 square. This is 9. This is twice of 1/4. Of course, twice of 1/4 is 1/2. 1/2, take away 1/2 from 9, we'll get 8 and 1/2. Okay, so that's the value of our p raised to 4 plus q raised to 4. So let's proceed with our next problem. But generally, again, the general strategy is to rewrite all of this in terms of sum and product of roots. So our next problem talks about actually the same with that one, but the question is different. If p and q are the roots of the quadratic equation 2x squared minus 4x plus 1 equals 0, form a new equation whose roots are 4p and 4q, p cube and q cube. Okay, so what we have here is that it's like saying that from 2x squared minus 4x plus 1 with roots p and q, we're going to form a new equation, new quadratic equation, but the roots of that new quadratic equation must be 4 times the roots. So the number 1, it says 4 times the roots of the original equation. Okay, so our goal here is we know that before in deriving in showing the relationship of the sum and product of roots. Where did it come from? Okay, we derive we derive it, and we found out that a quadratic equation can be expressed as x square, okay, x square minus x times the sum of roots plus product of roots, and that's equals to 0. So this one is actually our general guide here to form our new equation, meaning we just have to simply find the sum of that for this and the product of that for this, and get the value and substitute here. Okay, so meaning, oh yeah, we need to get the sum of this so that after we can substitute it here, and after that we need to get the product of that, we can substitute it here. So let's continue. So sum, I'll just write it here, sum of roots of new equation is 4p plus 4q, and we can write it as 4 times p plus q. We know that p plus q, is the sum of roots of the original equation. So that is negative times negative 4 divided by 2, and that is 2. So we can substitute it here. We can substitute it there. So we'll get 4 times 2 is 8. Okay? So meaning that the sum of the roots of the new equation is 8. Okay? So it doesn't matter if those roots are all real and all imaginary. Okay? So we have that. So meaning we can substitute that there. Okay? We can substitute that there. So the product of roots of the new equation is 4p times 4q. So that's 4p times 4q, and that is 16pq. We know that pq is actually just c over a, 1/2. So that is 16 1/2 of 16, and that gives us 8. Oh, they are the same. The sum of roots of new equation and the product of roots of the new equation are both equal to 8, but that's just coincidental. So using this, and that one, we can substitute that there and there. Then we have the new equation. Okay, therefore the new equation is x squared minus x times the sum of roots, which is 8, plus the product of roots, which is 8, equals 0. Okay, and that is obviously x squared minus 8x plus 8 equals 0. Then you got already your new equation. So your original equation is 2x squared minus 4x plus 1. If we're going to form a new equation such that the roots of that new equation is 4 times the roots of that given equation, we get this x squared minus 8x plus 8 equals 0. Okay, that's pretty easy. Okay, so number 2 is the same. In number 2, again, we're just using the same principle. We're just using the same guide here. We need to get the sum of p cube and q cube. It's like saying that the roots of the new equation are cubes of the old roots, cubes of the roots of the given equation here, because p and q are the roots of 2x squared minus 4x plus 1. So again, let's take the sum. We already know the value of p plus q and pq. So it's like the same with the previous problem. We're going to express p cube and q cube as sum p plus q and pq, because that's the available identity that we can substitute. Not really identity, but equivalent expression that we can rewrite into. So we have number 2. We let's find first the sum of the roots of the new equation, that is p cube plus q cube. And we know a while ago that this is just um, p plus q, p square plus q square minus 2pq. And we know that p plus q before. Remember that this problem is just the same with the previous problem. But if it's different, you have to really to start from scratch and find it. It's just the same with the previous problem. Remember here. And we know that p plus q square is 3 already. Okay. So we can just substitute it here. So p plus q is actually 2. P plus q square is 3 minus 2 times. Actually have already the value of p cube plus q cube before, because we just solved it before here in problem 3, and that's 5. Okay, remember that's 5, but we have to show it anyway. So 3 times 2 times pq is 1/2. So I'll just gonna write it that way. 1/2. This becomes no, this is wrong. It should be, we are not expanding actually, so there's no 1/2, and that is 3 minus 1/2 is 2 and 1/2. 5 over 2 times 2 is 5. Okay, so we have the sum of the product of the new roots. Let's go with the product. The product is p cube times q cube, which is can be written as p cube pq cube, and we have pq cube, which is 1/2 cube, and that is 1/8. Okay, so we just have to substitute them into x squared minus x, sum of roots plus product of roots equals to 0. Okay, and we simply need to substitute it there, that one and that one. We can now form our new equation. So our new equation is x times 5 plus 1/8 equals 0. You'll get, of course, x squared minus 5x plus 1 over 8 equals 0. Now, the problem states that there is no restriction in the coefficient of the variable. The coefficient, let's say, there's no stated condition there, another requirement. But if the problem states that your new equation must have an integral coefficient, okay, meaning the coefficients, the 1, the 5, the 1, 8 must be all integers or negative and positive whole numbers, including 0. Okay, so it's just saying that if the problem says the coefficient must be integral, so we need to get rid of 8. Okay, so by simply multiplying it by 8. So you'll have 8x squared minus 40x plus 1 equals 0. If that's the case. That's it.